Next Wednesday, we are going to talk about the Dawn probe as it approaches Ceres. Okay, so the time is coming for this to happen. So we are going to be doing a lot on that. And hopefully that is going to give us some ideas also for our space projects, okay, and the space celebration. All right, so next Wednesday we are probably going to focus here on Dawn. All right. Okay. Let's see what else do we have. Hi guys. Um, Today we are going to do a lesson on the earthquakes and tsunamis. Okay, so let me see in the module of the day. We have okay, so it's the last part here of this unit, and I have here an introductory video. I have a link to a couple of videos. We are going to watch pieces of that, but I encourage you to watch all of them, especially this one of the Japan tsunami, how it happened. It's actually very interesting. It's about 46 minutes long, but it's a very interesting video showing both the earthquake and the tsunami. Okay, so let's see. All right, let's see. Macy, you says the lesson was not posted, so I couldn't read it for today. I know, right? How do I get to the discussion? This unit goes so fast. Yeah, all the units go fast. So Macy, what do you mean that the lesson was not posted? So this lesson that wasn't posted before today, and that is correct. I usually kind of have to juggle a bunch of things, and so I finish the preparation and publishing the materials for the lesson right then and there. Okay, so you say I was not there, like it was not there like 10 minutes ago, and it wasn't there. Yes, that is true, Macy. You are right. Time is of the essence for me. So I prepare during the week, but I put all the materials here and the lesson together right before class. So usually you will have the access to these materials, and I point them out during the lesson right after the lesson. Is that okay? Mm-hmm. Okay. But shouldn't we be able to study the lesson before the go-to-meeting? You may see that would be the ideal. And in future years, as we have the materials already developed and I don't have to do the development and the teaching of the classes, then that is how we should be. Okay, so as it is now, because of my lack of time, I'm going to try to see if I can be better and post the lesson beforehand for you and for the other students. Okay, but here during the lesson I'm going to point out to the links and the things that you have available, and then study them afterwards, I guess. Okay, but I'll try to be better and see if I can catch up and post the materials before. Okay, is that all right, Macy? Would that be okay? So as it is, we have these links to a couple of videos. I have also some articles, the Wikipedia articles on earthquakes and tsunamis, and then a couple of links to talks given by Elder Oaks and Elder, let me see this one. Okay, Elder Ballard. All right, so we are going to talk about these two today. Okay, so we have some related questions, and then some activities, some of the assignments here. The required assignment that I have for the lesson today, I think that is going to be interesting, especially for those who like writing. what I would like you to write is kind of a story, okay, an imaginative story about what would happen to you and your family if you were in the middle of an earthquake or a tsunami. Okay, so if the area where you live were hit by one of these events, and so I would like you to write a story in past tense, okay, as if you were telling this to a friend, what happened, okay? And think, use your imagination, but remain realistic, okay? Think about things how they would really happen. What would you do? What would your family do? Okay? And imagine that the damage is similar to what you would see in real earthquakes and tsunami situations. Okay. So Riley, Rodney, if you can keep helping Riley on a private chat or, well, but he's not on the chat. So, well, let's see. No, he is in the chat. So he posted something in the chat.
Riley, she's one of my neighbors. I'm here. Oh, you can speak now.
Hey, excellent. All right.
Yeah, I got on the call. I figured it out.
Okay. So we are all good. Excellent.
First time, it sounds like.
How Sabrina is asking, how long should the story be? Okay, I put the length actually of about how much I want you to write. Okay, so about 3 pages of writing, and so focus kind of on maybe the first few days. Okay, what would happen immediately after? How do you survive? How do you organize yourself, your family, and things like that in order to survive a situation like that?
How big of an earthquake?
A big one.
A big one.
Yeah. So about similar to what we are going to see here in Japan. So the one that happened in Japan in 2011, that was actually an earthquake and a tsunami, was of magnitude 9, 8.8 to 9. So really, really something. Annika says that you actually weathered an earthquake, just that there was no damage. Okay?
Yeah.
So
I felt I was on the sidewalk, and the sidewalk started moving a little bit. It's like, that's why I asked how big of an earthquake. Like, we went out for pizza after that earthquake.
Yeah, so that wouldn't be very much to write, 3 pages, all right? So Ashling asked, don't earthquakes cause tsunamis? Yes, most of the time, tsunamis are caused by earthquakes. There are some other cases where tsunamis are caused by some other events, some other things, but most of the times the earthquakes are caused by the tsunamis are caused by earthquakes. Okay, so let's go and see a little bit here on this video, all right, that talks about earthquakes. So let's see if we can watch this clip.
When we're least prepared, disaster can strike. And few disasters are as unsettling as an earthquake.
Okay, so see, the shaking is quite large. Okay. When the cameras go off, it's because the cameras break. Yeah.
My guess is that earthquakes are really so...
Let's see if we can...
Every day, the Earth is shaken by hundreds of small earthquakes. Most go unnoticed. They usually occur along the boundaries of the thin plates that cover the Earth like an...
So you see how the earthquakes happen, and usually most of them happen along the fault lines, all right, that we have been talking about.
Eggshell. Driven by the heat deep within the Earth's core, the plates grind against each other on long lines called faults. When the plates find their motion blocked, stress builds up. Finally, the fault gives way. The released energy races through the Earth in the form of seismic waves. For much of the world, the movement of plates like these is also an indispensable creative force.
If we didn't have earthquakes,
Okay, so here you see the San Andreas Fault. This is a very, very distinguishable feature in California. Okay, and that is one of the areas where a lot of earthquakes happen and are caused that. Christopher says the energy released in an earthquake is equivalent to several nuclear bombs. Yes, that is correct. The Earth has a lot of energy, and as the plate tectonics move, as they move against each other, what happens is that sometimes they kind of catch. So let's suppose that the plates are not smooth in their boundaries, okay? So let's suppose that they catch, how my knuckles are kind of locked there, and that one of the plates is really pushing. Well, the other one is going to stay locked until something gives way. Can you see? I'm pushing with this arm. This one is just locking here, all right? But at some point it's going to give. When it gives, it releases all that energy that is stored, and that is what causes the earthquake. Okay, so that is what builds the energy. So I'm about 47. Okay, just for curiosity, just as a note. All right, so that is kind of how the energy builds up. All right. And we are going to see here in the Japan video, okay? All right, this documentary, this is the one that I really want you to watch the whole way. It's really, really interesting.
Beneath 6 kilometers of water, the Earth was distorting. A vast, slow-motion collision.
Okay, so now imagine in the San Andreas Fault, in the case of the San Andreas Fault, the fault, okay, is over the surface, all right? So in this case, there's not going to be a cause for a tsunami. In here, in the case of Japan, the fault was, like it says here in the video, under 6 kilometers of water, all right? So it's at the bottom of the ocean.
The Earth's crust is made up of several continent-sized slabs of rock, tectonic plates. Japan lies on a boundary between these plates. The Pacific plate is ramming into it at 8 centimeters a year, about the same speed your fingernails grow. The Pacific plate drives underneath it, snagging and catching as it goes.
Did you hear that? The speed at which the Pacific plate moves is about 8 centimeters per year, okay? And that is about how fast your nails grow, okay? I thought that was a good analogy to let you see the movement, okay, of things.
The plate that Japan sits on compresses and buckles under the strain.
What type of convergence zone is this? As we were studying the different types of convergence zones and fault lines, what type of convergence zone is this one? 8 centimeters per year. Yeah, excellent. That is really good. Thank you. So that is the amount of movement that happens. Now, think about, put the ruler again there, Rodney, okay, if you can. Put it there on the screen and point there, 8 centimeters. So that is the distance, but that is the distance over the whole fault line. All right, so we are talking about miles, thousands of miles around the Pacific Ocean that thing is moving. Okay, and imagine the amount of rock that would move, the mass of that movement. Okay, so, oh, I'm sorry that your connection is bad. Okay, so if your connection is bad, you can always try to catch up, afterwards watching the video. So it is really incredible when you think about the amount of the massive energy that is caused to move all that rock. Okay. Now, what type of of zone is this? Okay.
No, take off.
So we remember that we saw that there's basically three types of fault lines. What type is this one? Emma says it would be a subduction. Excellent. That is correct. Yes. So it's a subduction zone. So the Pacific plate is here being grinded and being subducted underneath the Japan plate. Okay. So let's see how the animation keeps going.
Over decades and centuries, immense stresses build up.
The energy that drove this earthquake.
Did you see that, how it happened? Let's play that part again. So the surface of the zones of the plates here is not smooth. Here in this, it looks kind of smooth and so on, but it's not smooth. So these are basically rocks that are grinding against each other. And so what happens is that as the Pacific plate moves down, it catches, it grabs the other plate, the Japanese plate, and it starts moving with it down. Okay, that puts a lot of pressure on this area because this is solid rock. It's not elastic, and so that is kind of like putting pressure on a metal plate, pushing it down. At some point, it's going to release. When it releases, it causes an earthquake, and it is an all of a sudden
under the
move.
strain. Over decades and centuries,
Okay,
immense stresses build up.
we would see there the move, okay, of the zone. Let's see if I can stop it right. Okay, no. Okay, let's see that again.
2011 at 2:46 p.m. Japanese time. The stresses reached breaking point.
All right, so at that point, when the stress reaches that breaking point and is released, the place where the movement happens, okay, and where the earthquake starts. Did you see that in the animation they show it kind of underneath here? That is called the hypocenter. Okay, hypocenter. I'm going to type it. Okay, that is the hypocenter of the earthquake. That is the place beneath the surface where the earthquake begins. Okay, why is it called hypocenter? What is the meaning of hypo?
It's where all the energy is built up. It's the center of all the energy.
That is correct. It's the center of all the energy, and it's really where the earthquake starts. Okay, now related to earthquakes, you may have heard. Okay, excellent. Thank you, Annika. All right, and the word hypo means below. Okay. Now, excellent, Emma. There you go. So you are all onto it. There, that is really good. So hypo means below. So that is really where the earthquake starts. Now, many times you may have heard of, related to earthquakes, to the word epicenter. Okay. What is the epicenter of the earthquake? What would be the epicenter of the earthquake? Is exactly directly above the hypocenter. Okay, and so it's the place where the earthquake starts above ground. Okay, so it's the point above the hypocenter. Okay, where the seismic waves start expanding and transferring on the surface of the earth. Okay, epi means above. Okay, so that is the hypocenter and the epicenter. There you have that, okay, that distinction. That's the surface. And as let's see if we can watch a couple of other areas here. All right, let's see this part. Let's go a little bit back. Let's see this. Okay.
That devastated Hiroshima. This event was probably 2 million of those, a really huge amount of energy.
So this earthquake, someone was saying that is several atomic bombs. This is 2 million of those atomic bombs. Okay, that is the force that it would have. Mm-hmm. Okay. Yes, so this earthquake was actually very, very powerful. It was the most powerful earthquake in Japan's recorded history of earthquakes. Okay, so very, very, very powerful. So this one was like 2 million atomic bombs. Mm-hmm. Let's keep watching some.
Shockwaves radiated out.
So there you see the epicenter, okay, and then how the shock waves, okay, radiate out. So Rodney asked, 2 million atomic bombs would wipe out all life. Yes, because of the amount of radiation. Okay, so can you see the difference? Here we are talking about not radiation, not atomic radiation, that causes cancer and burning and heat. Here we are talking about the energy itself, energy that is translated, in the case of an earthquake, on movement of mass. Okay, so that is why it doesn't wipe out, earthquakes don't wipe out as much life as an atomic bomb, because the atomic bomb basically, through the radiation, burns people. Okay, the earthquake moves things. All right, so we are talking about energy, but it's a different kind of energy. So is that clear what we mean by the energy and the difference between an atomic bomb energy and an earthquake energy?
I just wanted to know, how do they measure the force or energy like that?
Mm-hmm.
You said they measured the movement of the mass, but they use different masses. So how do you measure it? There needs to be a common denominator, I think.
So the what you measure is precisely that, the movement of mass. Okay, and so you estimate by the amount of movement that is registered in the seismographs. Okay, you can calculate, okay, this earthquake is moving all this mass. You multiply that by the area that the earthquake affected, the mass of all that area, and then you say that is the amount of energy that it would take to move all that mass. Okay, so it's a kind of an estimate. All right, but that is basically how it is calculated. Mm-hmm. All right. Some ask, what would be the power in relation to dynamite? Well, I don't know. It would be a lot more. Okay, so calculate how much it would be one atomic bomb on dynamite units. Okay, so these are all, of course, estimates, and they are not precise because it's not the issue is not to be precise really on the measurement. Okay, it's a matter of just studying and being able to see in relation to other things. Okay, so let's see. This is the epicenter where the earthquake first radiated out, and see how the shock waves radiate.
Known as P waves, traveled at 6 kilometers a second.
So the P waves are the first waves that the earthquake emits, and they are very, very fast. They go at 6 kilometers per second. Okay, so it really moves very fast.
Japan's detection systems picked them up instantly. Within seconds, before anyone realized what was going on, automatic warnings flashed across the country. A computer-generated announcement even interrupted a Japanese parliament broadcast. By the time the warning system kicked in, the coastal city of Sendai, just 130 kilometers from where the earthquake originated, was shaking.
Okay, so yes, the seismic waves propagate around the surface of the earth, both on ocean and on ground, as ripples, okay, in a pond. All right, and the P waves propagate faster. And that is what Japan use and other countries use as an early warning system. All right. So in this case, the Japanese, because they are basically their whole island is on fault lines, they have all these systems ready to be able to try to predict or announce when it's going to happen. But okay, so it was really only even seconds ahead make a big difference. Here they are saying that the city of Sendai, okay, by the time the warnings kick in, they were already shaking. The P waves are not very powerful. They are fast, but they are not very powerful. The P waves are not what caused the main destruction of an earthquake.
The slower but more destructive shock waves, called S waves, had now arrived. These waves travel at 3 kilometers a second. They threw north.
Okay, so did you hear that? So the S waves, that are the actual shock waves of the earthquake, they travel at 3 kilometers per second. So half the speed. So depending on how fast you are from the epicenter, you would have basically, the square amount of time between the P waves and the S waves. Okay, and the S waves are the ones that destroy things.
Northeast Japan into chaos.
So this is a camera on top of a building. Those are
As the shock waves raced outward, 150 kilometers southwest of the epicenter, they slammed past Fukushima Daiichi, an aging nuclear power station housing 6 reactors and generating 4.5 gigawatts of electricity for the local grid.
Okay, so here they talk about what happened. The atomic reactor shut down, but it was still very, very hot. Okay, and so they had to do things to brace it. There's one part here in this video, and I really want you to watch the whole thing. it talks about that the earthquake lasted like 5 minutes. Okay, let me see if I can, if there's one part that they talk about that. Let me see, I think that it was around that area. Okay. Okay, let's see these.
With 60 seconds warning, Tokyo was already braced.
So Tokyo, that is a lot further south from the epicenter, you know, they had 60 seconds of warning. Sendai didn't have much because they were right close to the epicenter. Mm-hmm.
But not for this. The quake lasted an unprecedented 5 minutes.
So imagine being in a roller coaster for 5 minutes, but you know that this roller coaster, there's nothing that was tested for security. Okay. So Sabrina, yes, you are right with that, and then we are going to see what happened with this earthquake, how it started the tsunami. Mm-hmm. Okay, so Rodney asked a very interesting question. What would you do if you had only 60 seconds to get ready for an earthquake? Okay, so try, when you do the assignment for this lesson, if you write this story, try to imagine all those things. What would you do? Okay, where would you go? Who would you gather? Would you pray? Would you have time to pray? Okay, so that is what I want you to think about.
One American geologist was in the city that day.
We expected it to end after 10, 15, 20 seconds, something like that, maybe a minute at the most. About minute 3 or 4, we were just all kind of astonished that it just kept going and going and going.
What is different about a big earthquake is that it begins, but it doesn't stop.
We're just looking at each other going, is this over yet? No, it's not. It's still going. It was kind of a growing realization that it was just getting bigger and bigger and bigger, and it had to be fairly close.
In a nearby park, an American tourist found the ground opening up at his feet. No one has ever filmed this happening before. The footage reveals a characteristic of earthquakes: liquefaction. As the ground is compressed, water is squeezed and forced to the surface.
Okay, we have earthquake right now.
Notice this.
Moving.
Notice the growth of the break.
See the cracks moving?
And think about this,
that
that
crack was not there.
this is a crack that you have no idea how deep it is.
The crack is getting bigger and smaller, going back and forth. And there is water coming up all over in the park right now.
See these pools of water, how they seep through, okay? Can you see how they actually are pushed up?
And here's a huge crack. And it's still moving. It's just going back and forth, swaying. It's making me kind of nervous. This land could just go, potentially. I don't know.
Yeah, this guy that was filming, that was the part that I wanted to show you. This guy that was basically filming this, you know, he really didn't know whether this was actually going to stay relatively close or it was going to just open up huge and swallow him, you know. So, but did you see how as the earth moves and moves in and out, it compresses, the water that is in the ground, okay, gets pushed up. Okay, that is the liquefaction effect. Mm-hmm. So yeah, that is really a scary occurrence. So Sabrina was saying that earthquakes that happen in the ocean cause tsunamis, and yes, that is what happened in this case. So remember that this movement, the movement here of the Earth by the shock waves, is now not the movement of the tectonic plates, but it's actually the ripple effect of that energy that is being released. All right. So can you see how the earthquake here is propagating and happening away from the epicenter, away from the place where that fault line was releasing the energy. Okay, so let's see about the tsunami. If we go a little further, let me see. Okay, I think that we can catch some of that over here. Okay.
Over centuries, the Japanese side of the tectonic fault line had been compressed and dragged downwards by the Pacific plate driving beneath it.
So this is the same animation, but it's going to show now, talk about
plate
the
behaves
tsunami.
just basically like a rubber block. It just compresses and like a spring like this. And when the earthquake happens, it springs back.
The sudden upward flip of such a huge slab of rock lifted a 6-kilometer deep mass of water upwards to the surface of the sea.
So that
As
is
it
the
collapsed
beginning
back,
of the tsunami.
Immense waves raced out across the ocean. Not like normal sea waves, more like shock waves from an explosion. Just a meter high, but over 100 kilometers from front to back, and traveling at terrifying speed.
All right. So you see here that the shock wave of that generates the tsunami is basically the wall of water above the between the epicenter and the surface of the ocean. We can see you. You are being recorded for all posterity with the light. Thank you. Okay. So what happens is that when the epicenter here pushes the water up, the water is going to be pushed up and then it's going to spread into a wave. Okay, this wave is not that high. A meter is 3 feet. Okay, so about this distance. All right, so about this distance here. It's not that high. All right, a little more, Rodney. A little more. No, more. Okay, there. Okay, that is about a meter. So that is not such a big wave, but the difference between this wave and other waves is that this is hundreds of kilometers in width. Okay, and it has so much energy that it propagates out really fast. All right, 500 miles an hour or something like that. So it's about the speed of a jet plane. Okay, how the wave propagates in all directions. All right, you see that it's propagating everywhere. The problem is what happens when that wave, that wall of 1 meter high of water, starts reaching shallow waters. Okay, let's see. So, that's something. So Spencer says a year or so after the tsunami, a big hollow piece of concrete washed up onto a beach in Oregon. All right. So Sabrina says that tsunamis are really hard to predict. Well, usually tsunamis happen, because of some catastrophic event that causes this type of wave. Okay, and the problem with the prediction of the tsunamis is that you don't know how high they are going to go once they reach the shore. Mm-hmm. And it's true that something that Sabrina says is that before the tsunami hits, the water in the shoreline retreats. It actually goes back, and then the wave hits. Okay, so if at any point you see if you live in a shoreline area, like in Hawaii or something like that, and you see the water actually retreating, what do?
You get to high ground.
You go high. You go inland high as fast as you can. All right.
Seashells are being discovered.
Not the right time. Not the right time. In fact, in this particular tsunami, it was very devastating in Japan because Japan was so close. But when it reached Hawaii, it wasn't that bad. All right, but people did run away and everything. The only casualty here in America, it was actually a guy that went into the beach when the water retreated. He went into the beach to take pictures or something, and then the wave washed him away. Okay, so you don't do that. Okay. Let's see some more of the footage here of the tsunami and what is the effect of that. Let me see if I catch some parts of that. Okay. So see, this is a wall that the Japanese had built around this city. It was 10 meters high, and they thought, okay, we are going to be okay behind this wall. All right, but the problem was that the tsunami was higher than that. Mm-hmm.
Measurements from tsunami monitoring stations along the coast were equally puzzling. The height of the wave varied dramatically from town to town. But why? The varying depth of the seabed was partly to blame. Where the water was deeper, the tsunami travelled faster and reached land more quickly. Another factor is the complex detail of cliffs, bays, and inlets along the shoreline.
See the speed at which the water moves.
It boils down to how the wave is focused and defocused by the geography or the topography of the coastline itself.
This is Ofunato, where the wave hit first. Deep water off the coast offered little resistance to the wave.
So
tsunami warnings did sound, but here there was little time to get to higher ground.
The best early warning system people would have had would have been the fact that there was an earthquake. And people have got used to the fact that if you have an earthquake, there is a possibility of a tsunami that will follow. But in the time scale they had, there was very little time or very little opportunity for escape.
The tsunami hit Ofunato just 20 minutes after the earthquake.
So did you hear that? Okay, so Ofunato was the first place where the tsunami hit Japan, but how much time did they have between the earthquake and the tsunami? It actually said 20 minutes. Okay, so let me see if I catch that part again. And so what was excellent, Christian? So what was the warning that the Japanese people had that the tsunami was probably going to happen? It was the earthquake. Okay, let's listen to that again.
If you have an earthquake, there is a possibility of a tsunami that will follow. But in the time scale they had, there was very little time or very little opportunity for escape.
The tsunami hit Ofunato just 20 minutes after the earthquake.
Water that actually hit the coast will
So-
be well in excess of 1 billion, probably 10 billion tons of water.
10 billion tons of water hitting there. Not a good thing. All right, so imagine the whole force of that. But see, with 20 minutes of warning, the Japanese people, a lot of people actually were able to escape as fast as they could, as much as they could, because they knew that a tsunami was very likely to happen after the earthquake. Okay, so that would be another sign.
That's a little bit like taking 1 million swimming pools and just emptying them onto the coastal areas of northeast Japan.
15 minutes later, the tsunami hit Sendai, 116 kilometers south.
15 minutes.
The area around
More.
the city is mostly farmland, low-lying, fertile, and flat. That's why the tsunami barely slowed as it smashed ashore. The flat land was perfect for an airport, too. It opened just 4 years ago. A kilometer from the coast, it was deluged.
So that's the airport there in Sendai.
It's very low-lying areas. There's nothing to stop it moving inland. And so it can move inland 6 to 7 kilometers without being impeded.
There's not much to slow it down, and because the wavelength of the tsunami is so big, it's not going to stop until it reaches something, reaches some sort of high ground, and it'll just keep on coming.
Now at this time, at this point, as you can imagine, this is no longer just water. Okay, Christopher says the water looks black. Yes, because it's really more of the consistency of, kind of very runny cement. So here you have that the water is just carrying stuff, carrying cars, houses, dirt, anything on the. So yeah, it's a huge combination of mud and things really that are moving all together. Okay, so in this case, in the case of Sendai, because there's no mountains, very flat coastline, the tsunami was able to go even 6 kilometers inland. So that is about 4 miles. So in this case, there were nowhere to hide, really. You couldn't sprint to the mountains, okay? But they had 35 minutes between the earthquake and the tsunami here in Sendai. Annika is fine because they're in Bolivia they are very, very high and landlocked. So, but see the approach.
Next to be hit was the Miyako coast, 180 kilometers back to the north. What happened here highlights another mystery. The area had good tsunami defenses. The residents were prepared. They should have been safe. Last time a tsunami hit here was half a century ago. In the aftermath of that tsunami, they built these 10-meter high seawalls, far higher than anyone thought they would need. Tsunami drills became a regular feature of life. Everyone knew what to do when the sirens sounded. On March the 11th, all along the coast, the sirens did sound, this time for real.
Go to the hill.
A tsunami was coming. This was not a drill.
Can you hear the sirens?
There's a hill outside of town that we're going to try to get to. Well, it's a precautionary measure, but I mean, you never know. This town has a lot of history with tsunamis and a lot of death from it, so they're taking it pretty seriously, obviously.
The warning saved the lives of some. This footage captures the moments after the sirens sounded.
Here it comes!
The tsunami breached the coastal defenses.
There it goes, the tsunami
Miyako's
over
high
the wall.
walls proved useless.
Now imagine being the person there on top of this house, filming this and seeing this and wondering, is this house going to hold up or not? Because you have no idea.
Countless people died here. The tsunami was 10 meters high. Why did their 10-meter high walls fail to stop it? With thousands.
So then it goes and explains the reason of why, if the tsunami was 10 meters high, why did the wall didn't stop the tsunami? Because it was about the same height. Why did it go over? Okay, so I'm not going to tell you why. I'm going to ask you actually to and invite you to watch this video, the whole thing, all right, and then find out why did the wall did not stop the tsunami. That most likely may be one of the questions in the forthcoming quiz. Okay. All right. So, okay. So that is basically the things that we have there on, on tsunamis and earthquakes and how they happen and why they happen in, in what areas they are and so on. Do you have any questions about this? Mm-hmm. Yeah, it is earth-shattering. Okay, so in this in the Wikipedia article on earthquakes, they have really lots of very important and good information about the earthquakes and how they happen. Here they have also, let's see, underneath, I think that is below, there are different pictures of different types of earthquakes. This one is interesting. This was an earthquake in 2001 in El Salvador, and the earthquake caused a landslide over the side of a mountain. All right, so you see here the catastrophic move of all this mountain down to the side. Mm-hmm. Let's see if they have, oh no, this is in the other article on tsunamis. But in this part of the article, it really explains the different types of fault lines and the different type of earthquakes that they cause. So when you have a divergence zone, okay, more of a normal split, the divergence zone, that causes earthquakes, but they are not that powerful. The earthquakes that are the most powerful are the thrust earthquakes, where you have a subduction zone, like the one here in Japan. In the case of a strike slip zone, like the San Andreas fault, where you have the two plates grinding against each other, that is of an intermediate type of power in the zone. Okay? All right. So this is lesson 24. Mm-hmm. Okay. So Annika says a landslide could actually happen here. No water, but plenty of loose rock. Yeah. And also there's a lot of, in that area in Bolivia, in the Andes, there's a lot of volcanic activity. So you would expect in areas like Bolivia that you would have earthquakes associated not so much with the movement of fault lines, but with volcanic activity. Okay, and also volcanoes can induce earthquakes. All right. The article on tsunamis is also very, very interesting. There's an animation of that, of how it happens, and pictures about the aftermath of very different tsunamis. This was a one that happened not too long ago in 2005, all right, in Indonesia. And again, the people had plenty of warning because the waters receded, and some people were smart enough to go to the mountains, but a lot of people thought that that was really cool and interesting, and they got killed by the tsunami. So it is important to know what to do and how to do it. These are the ones that I wanted to show you. So here we have, again, this is similar like the case that we saw in Japan, where you have a subducting plate and the overriding plate is being sucked or stuck together and compressed, okay, and is being distorted over time. This can happen over centuries, over a long, long period of time. But all this distortion actually puts pressure on the elasticity of the rock, okay, and at some point is going to snap, rupture whatever is keeping that plate stuck. It breaks, and that causes the earthquake. If there is water on top, then that is going to cause the tsunami and spread the water out and release it in waves. Okay? So here also, this one is a cool animation that shows why a 1 meter high wave in the ocean, why it turned into a 10-meter wall of water or more when it reaches shallow ground. Okay? And so you have that the wave propagates, but as soon as the ground starts elevating, the wave length, okay, of the wave increases because it has to push, that's all that energy increases the wavelength, okay, and that is why the tsunamis get higher as they reach the coastline. Okay, let's see if there are some comments here. Okay, let's see. Ohio is safe, it's just clay. Yes, I would say that it is, you know. So sometimes earthquakes could happen in those areas, but they are usually kind of mitigated a lot. So are there I don't catch the question here. So if you want to ask the question, let me unmute. Okay. Any comments or something? All right. So now, if you think about yeah, so yeah, the water is not, you know, something that you can just, oh, I'm just going to ride a wave. It really would smack you into pieces, frankly. I like to do body surfing whenever I go to the ocean, and I have been hit with some waves that I'm like, okay, I'm lucky that I survived that one. Yeah. If you are a submarine, okay, if you're a submarine and you are under the water, you actually wouldn't feel the wave, okay? So even though the wave would happen, you would probably not feel much of that. The wave propagates really on the surface because of the difference between the water tension and the air, okay? So that is what causes the wave to happen. When you think about it, once you submerge underneath the water, you know, the waves and wind and everything on top could do whatever, and you don't feel almost anything under the water. Okay. So let me see. Now, one of the things that I want to talk about is that I did a little search in the scriptures about earthquakes, okay, and there's lots of scriptures that talk about earthquakes. And especially there's many scriptures that talk about earthquakes happening in the last days, okay? So, for example, here in section 88, it says, "And after your testimony cometh wrath and indignation upon the people." So if people refuse the message of the gospel, then there's going to come, "For after your testimony cometh the testimony of earthquakes, that shall cause groanings in the midst of her, of the earth, and men shall fall upon the ground and shall not be able to stand. And also cometh the testimony of the voice of thunderings, and the voice of lightnings, and the voice of tempest, and the voice of the waves of the sea heaving themselves beyond their bounds." That is basically a definition of the tsunami. Okay? So, "And all things shall be in commotion, and surely men's hearts shall fail them, for fear shall come upon all people." And then this section keeps talking about all the signs of the second coming, of what is going to happen because of iniquity and so on. All right. What is the counsel that the Lord gives to us? "Abide ye in the liberty wherewith ye are made free. Entangle not yourselves in sin, but let your hands be clean until the Lord comes." Okay. So what is the best protection that we have? What is the best protection that we have against these earthquakes and calamities, tsunamis, and destruction that are going to happen as the second coming of the Lord gets closer and closer? What is the best protection that we have? The Spirit, our faith, okay, going to the temple, get revelation, trusting God, okay. I really think that our testimonies, yeah, all those things are, tithing is a fire insurance, yeah, prayer. I really like how the Lord puts it here, okay, in the scriptures that says, "Entangle not yourselves in sin, but let your hands be clean until the Lord comes." Okay. So really, it is interesting that our how worthy we are of going to the temple, how are we living the gospel, is probably the best preparation that we have against these calamities. Okay, no matter what happens, whether we live and survive these earthquakes and things or we die, the best thing that we can do is really not to entangle ourselves with sin and keep our hands clean. Okay, because that is going to basically ensure us not just surviving the calamities, but also, what happens after that. Okay. So that when you do the assignment for this lesson, okay, to write this story, that is kind of one of the things that I want you to think. Not just the issue about, the damage, the destruction, and so on, but try to think deeply about how would you feel, what would you do, and how living the gospel would affect you, your family, and those around you. what would be the difference between how you encounter a situation like this and other people that don't have the gospel? What would happen with that? Does that make sense? Okay. I also really invite you to look and listen to these talks, The Joy of Hope Fulfilled and Preparation, okay, Preparation for the Second Coming by Elder Oaks. Very, very important talk, and he talks about, the signs of the second coming and what would happen. Yes, Rodney, puts there of hymn number 30, okay, and should we die before our journey is through, a happy day, all is well. Yeah. So it really, no one dies before their journey is fulfilled, but sometimes we may cut our journey close, or the Lord may say, well, that is enough, and send an earthquake and cut a lot of journeys off suddenly. Okay. So that is the things that I want you to think about when you think about these powerful forces of the earth and how the earth kind of reacts to the different things. How can we be prepared and how can we react to those? Yeah. Yeah, in the hymn it means before the pioneers reach the Salt Lake Valley, but it could mean any type of journey that we are on. Okay, each one of us is in a journey through this life. All right, so let's finish class with a prayer. I thank you for your participation, all your questions and attention, and I hope that this was an interesting class. Okay, let's see, let me unmute people. And who would like to offer a prayer for us today? Okay, let's see. Would you like to? Rodney, would you like to offer a prayer, please?
Yes.
Thank you.
Prayer time, guys. Shh. Dear kind Heavenly Father, we're thankful for this day. We're thankful for the opportunity to learn. Please help us apply these lessons into our daily lives. Help us to seek out knowledge and to learn and grow. We're thankful for Papa, and please bless him with health and strength. We're thankful for the time and effort he puts into teaching us, and that he always points out the simple and true lessons that we need to hear. And these things we pray for in the name of thy Son, Jesus Christ. Amen.
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 Thank you very, very much. All right.